afternoon, everybody. I'm David Paul, Chief Meteorologist here at KHOU 11 News. We are live. We're here in the Weather Center, and this is our continuation of the Weather Classroom. We've been doing this for almost now 3 weeks, coming up on 2.5, 3 weeks. We're going to continue to do this at 2 o'clock, so kids of all ages, make sure if you're here joining us for this lesson, that's great, and we'll see you again on Friday, and then we'll start it up again on Monday, Tuesday, Wednesday, Thursday, Friday of next week. And we're going to try to keep this going until we finally get back to some sort of normal. I hope you guys are having a good afternoon. We're going to talk about lightning today, in case you were wondering, the obvious, lightning. So lightning is, it's one of the most studied, misunderstood, and still misunderstood to this day phenomenons that Mother Nature produces. It's one of the most powerful. These lightning strikes can be as hot as 50,000 degrees. That's hotter than the visible surface of the sun. That's only 10,000 degrees. So there's a lot going on with lightning. It's well, let's just dive into the lesson here, and I'll show you what lightning is and a little bit about it. And this is going to be the first of a couple of lessons on lightning. We'll go into lightning safety and lightning mythology as we go over the next couple of days. Oh, lightning mythology. So this is also Zeus, if you remember from mythology. Zeus on Mount Olympus, he was the one who possessed the lightning bolt. And they gave that to the most powerful god because the lightning bolts did the most damage to human beings. People struck by lightning were thought to be out of favor with Zeus. We know a little bit more about it today, and here's a few things about lightning that maybe you didn't know. What is lightning? It is a giant spark, a release of static electricity. So it is electrical on a grand scale. We'll talk more about that in a minute. How many strikes are there on the planet Earth at any one given time? Well, there are 40 lightning strikes per second on planet Earth. A lot of thunderstorms going on right now across the globe. We may have some here tomorrow. Lightning's heat. It is the incredible heat of that lightning bolt, which can be between 10 and 50,000 degrees, that creates the thunder. It causes the channel through which that lightning passes. The air literally explodes, and that sends out a shock wave, and eventually gets to your ear, and you hear that big, beautiful peal of thunder. All right, lightning. Lightning very often, in fact, most often, when it strikes tall objects. And here's a perfect example of an incredible picture of a lightning bolt coming down and hitting that tree. Now, why would it do that? It's because lightning wants to take the path of least resistance. You've got an electrical charge at the cloud base, you've got an electrical charge at the surface. They become huge, and Mother Nature wants to try to balance things out. And in order to do that, she'll send down what's called a step leader, and this happens very quickly, almost at the speed of light, and it's almost perfectly invisible. But you see how it takes this crooked path through the air? That's because that electrical charge is trying to find the path of least resistance through the air to that electrical charge down at the surface. And whatever that path of least resistance is, it will take it until it reaches that electrical charge that builds up at the surface. And those two want to get together in the easiest, quickest way. And the quickest way is a tall object, which is closer to the cloud base. And so that's why lightning strikes tall objects. We'll talk more about lightning safety tomorrow. But I think obviously you can see this is why you do not want to run under a tree to get out of the rain when a thunderstorm is coming. So that's cloud to ground lightning. We also have cloud to cloud and cloud to air. Lightning doesn't always hit the ground. Quite often, especially at night, you'll see the cloud flash, but there's no lightning strike or bolt that hits the ground. That's because quite often lightning travels from cloud to cloud. This is a perfect example. Here's a lightning strike that is not going to the ground. It's going back up into the cloud. So you've got perhaps a negative charge here and a positive charge here, and they become very, very large. And Mother Nature wants to equalize that. And so she'll create a path just like a wire connecting two big charges of electricity together and releasing them in the form of a lightning bolt. So that's cloud to cloud, and this one appears to be cloud to air. It's just kind of dissipating into the air. That can also happen. It doesn't have to actually hit anything. It is cloud to air. There are some charges here that it is in the process of rebalancing. That's a beautiful picture. Have you ever seen this? I remember the first time I saw this phenomenon. I was driving home with my family. I was about 8 years old. We were on the way home from Dallas. It was early in the morning, and a thunderstorm had rolled through. And on the backside, this incredible lightning show occurred. And it was almost like the lightning bolt was moving in slow motion as it spread out like fingers. See how that's spreading out? And it does quite often. This moves very, very slowly in comparison to regular lightning. This is called spider lightning, and it is one of the most beautiful and eerie lightning phenomenons that you will ever see. And this is cloud to cloud. It originates at the cloud base and then spreads out through, quite often, either the anvil cloud left over from a thunderstorm or on the backside in the stratus deck. And as it pushes through that cloud, it spreads out like fingers, like the fingers of a witch's broom is what I thought it looked like, and it just fascinated me. It was incredible. This is actually a very interesting picture because not only do we have the spider lightning going off in the cloud, but look here, there's another lightning strike taking place at the cloud base. And you may notice, you see this little fuzzy area? So that's where the heaviest rain is taking place in this particular storm. And that is where most lightning strikes occur. They occur in that rain shaft. The area of heaviest rain is where most cloud-to-ground lightning strikes occur. So if you're in an area of heavy rain and you can hear thunder, you're probably near the most likely spot to see cloud-to-ground lightning, and you definitely need to take cover in a house, a building, or a car are places to be. And again, tomorrow's lesson will be more on lightning safety. Okay, so that's your beautiful lightning strike. Let's talk about what's going on here inside the cloud. How is lightning made in the first place? So inside of a thunderstorm, you have convection. That's an up and down motion inside that big cloud. That convection up and down is what makes hailstones. If you joined us for our lesson on hail yesterday, Erica was talking about how this up and down motion is what carries raindrops, liquid raindrops, up above the freezing level. They freeze up here, they get heavy, they come down, but they don't make it down and fall because they get caught in an updraft and they go back up, and each trip they make through the storm, they get bigger and bigger and bigger with a layer of ice. So that's called convection, up and down motion. You can see it when you boil water if you're making spaghetti. Make spaghetti tonight and help mom and dad and watch the pot boil, and you will see, if you watch it, when it's boiling, you'll see there's up and down motion inside that boiling pot of water as it gets hot. And so that's what happens. We get that convection. So that's what makes hail. It's also what electrifies the cloud and separates the charges, that up and down convection. And here's what happens. That up and down motion causes the positive and negative charges to be split apart, and they'll gather, the positive charges at the top and the negative charges at the bottom. Now, we talked about how lightning is a gigantic release of electricity. So think about this. You've got this gigantic, here we go, think about this. A battery is, what are we doing here? We're about let's be conservative, 2 inches long and a 1/2 inch across. There's your Duracell battery. And it's storing electricity, and you probably have had these in your toy or electrical device, and it releases electricity so the device can work. 2 inches tall by a 1/2 inch across. Meanwhile, that thunderhead, that thunderstorm, think about the size of this. They can be as high as 9 miles. That's a 9-mile high battery, so to speak. It's not exactly like a battery, but it's a good way to think about it. 9 miles high. A storm like that can be, let's just go with 3 miles across, inches, 3 miles across. So you have in the atmosphere, in a thunderstorm, a battery, so to speak, that is almost unimaginable how big it really is. So you get these tremendous buildups of positive charges and negative charges, and it's just the forces at work here are very, very large. A lightning bolt can release, you probably, let's see, Back to the Future, 1.21 gigawatts. And it's a lightning bolt that they use to send the car back to the future. Well, it is theorized, and we don't exactly know how much energy is in a lightning bolt. It's very difficult to measure. One of the many things we don't quite understand about it, but we know that it's hot enough to melt sand in the desert, melt the sand. Think about that. It melts the sand when it hits the desert floor, and then that turns into glass. So there is just a tremendous, think about how hot a furnace has to get to melt glass if you've ever seen people working with glass. So lightning hot enough to melt glass. So it's a huge release of energy. And here's how this mechanically works in the atmosphere. So here's our cloud, here's our battery, positive charges at the top, negative charges at the bottom. Remember, this is very important, you can write this down. Opposites attract, especially when it comes to electricity. Opposites attract. You've played with magnets before. If you click certain ends together, positive and negative end together, they stick together. Positive and negative, they attract. If you try to press the two positive sides together, they repel each other. I always loved that as a kid too. So we've got this gigantic battery, so to speak, store of static electricity, and there are all the negative charges. And they're so strong that even, 800 feet, 700 feet below the cloud base, look what's happening. It's attracting positive charges at the ground. And it attracts a huge amount. You will get a bubble of positively charged ions at the surface, while you have a bubble of negatively charged particles, ions, at the cloud base. And so this is building up a big, what's called a potential. It's out of balance. And nature wants to try to balance things out. So she's going to do that, and she does that with electricity by making a lightning strike. So that's what's happening first. Here's where the lightning strike happens, and this part happens very, very quickly, and it's almost invisible, and it happens at the speed of light, and you really don't see this. You see that little track coming out of the cloud? So those are the negatively charged particles, and they're going down to they're trying to head down to the surface because they want to get together with those positive charges. It's like those two magnets sticking together. And that little thing coming down is something called a step leader. And look what's happening at the same time. These positive charges at the surface, they want to get to that cloud base in the worst way. They want to get together. And what's the easiest path for them? Well, it's to go up a tall object. So they climb trees and buildings and power poles, and these two charges are trying to get together. Nature wants to balance this thing out, and she's going to do it violently. When these two gigantic electrical charges finally do get together, you get that flash of lightning, and there's your lightning strike. And what actually is happening with cloud to ground, even we call it cloud to ground because those negative charges are coming down, but the flash of light that you see is actually these positive charges racing up that channel, that path of least resistance channel. They race up that channel, and when they do that, it balances back out the atmosphere. See, the positive charges get up here, and they balance out with the negative, and so Mother Nature's happy again until the next lightning strike builds up. But it's those positive charges going up that channel that creates the flash of lightning that you see. It actually, part of it is going ground to cloud. And this is the most surprising, most powerful, and most dangerous type of lightning strike. Have you ever heard of a bolt from the blue? Maybe you've heard the phrase, "It just came out of the blue." This is where that phrase comes from. This is the origin of it. So a bolt from the blue, what is that? Well, take a look. I'm going to draw the outline of our storm here. Here's the storm. There's our storm. There's the cloud base. Here's the storm. Look at where this lightning strike not only is originating from, but striking the ground or a tree or a building. This is coming off the top of the storm. Now, remember, we looked at those negative charges build up at the cloud base. That's usually how it happens. We get negative charges down here. We get positive charges that gather below it for a cloud to ground strike. But remember, opposites attract, and that convection that's going on inside this storm, it separates the charges. So at the top of the cloud, you'll get, instead of negative, you'll get a huge buildup of positive. Now, because the cloud base is close to the ground, you get most of your lightning strikes down here, underneath the heavy rain, because they're closer together. It's easier for nature to get a pathway and have them meet and create those lightning strikes. So these cloud-to-ground strikes are more numerous, and they're much weaker than these positive strikes that leap off the top of the cloud. And that's because, so read this. So bolt from the blue can hit 10 to 25 miles from the parent storm. So while we're building up all these negative charges down here, all these positive charges down here on the bottom, these are all positive, here's all your negative. We're building up a gigantic store of positive electricity at the top of that cloud. And we've got positive at the ground underneath the cloud, but over here you'll get a buildup on each side of the storm, you'll get a buildup of negative charges. And sometimes the potential, the difference between the positive charges at the top of the cloud and the negative charges out far away from the storm, well, Mother Nature wants to balance this out. And when she does this type of balancing, it creates a very violent and powerful lightning bolt. These are the most powerful. These bolts from the blue that have so much energy, they can connect 2 points 10 to 25 miles apart, are the ones that are as hot as 50,000 degrees. That's one reason why they're so dangerous. But obviously, if you're a person over here and you're standing here and you're like, wow, that storm has moved through. Maybe that thing is 10, 15 miles away, off in the distance. And the next thing you know, lightning strikes right near you. That's a bolt from the blue. You think the storm has passed, but in reality, you're still in range of those positive lightning strikes that come off the top of the cloud. I was victim of this one time. Many years ago, it was a summer afternoon, thunderstorm popped up out of nowhere. I was in my car, I waited it out, I was waiting to get gas. And so the storm moved by. They were moving very quickly. It moved north, and I waited, and it was probably 5 miles to the north. And so I got out, and I was pumping gas. Think about that. So I'm pumping gas, and literally I've got the gas in my hand, the thing, and I'm squeezing it, and gas is flowing in, and I'm watching the storm, and I can still hear the thunder out there, which is a rule you don't want to break. And all of a sudden, out of nowhere, an electrical shock went up my arm and through me, and I felt like a jolt. And there was that snap, instantaneous snap, and then just a huge thunder. And what had happened was, one of these positive, powerful strikes had jumped from that cloud that was 8 or so miles away and hit the metal roof that you find quite often at gas stations. The metal roof had taken most of the energy, the electricity from that lightning strike, was acting like a tree, but some of that energy popped right through my arm while I'm pumping gas into my car. And it crossed my mind that was a moment where there was a lot of potential for a major problem there. So that is one of the many reasons why I remained. It's not that I'm scared of lightning, it's just that I know what it can do. When I became a soccer coach, I made sure if you can hear thunder, if you can hear it, you're still in range of that lightning. If you hear thunder, nope, it's not safe to be out because those bolts can jump, and I mean, it's unlikely that you would be hit, but it can happen. And you know it can happen, and so that's why they shut down the swimming pools or they stop the softball games, because that type of a bolt can be incredibly dangerous, and those are the ones that kill most people. And lightning can kill. So it is something dangerous and something we try to learn more about and study and track. So that is our first lesson in lightning, but I want to end with this. So lightning, back to this one, lightning striking tall objects. So you do not want to go and run under a tree to get out of the rain so you don't get wet during a rainstorm, because in Houston those can very quickly become thunderstorms, and that's would be a very dangerous place for you to be. So tomorrow what we're going to talk about is, what do you do? Where do you go? What's safe and what's not safe when there's lightning and thunder raging from the sky? So tomorrow's lesson will be about lightning safety. And Randy is listening. Randy, before we go, anybody out there that we can give a shout out to?
Yeah, absolutely. We've got, hold on one second, Gunner, 6 years old.
Hey Gunner, how you doing? Nice for you to join us.
Okay, and let's see, Tammy's watching.
Hi Tammy.
Let's see, I'm trying to find some.
By the way, that was 6-year-old Gunner.
6-year-old Gunner.
Yes, I know these young meteorologists, they start young.
Yep, absolutely. Let's see, Foster Elementary School.
All right.
Here in Washington.
Hey Foster Elementary. Hey guys. Well look, whether you're a teacher or a student, a parent or young at heart or young at all, thanks for joining us. Again, tomorrow's lesson on lightning is going to be more about lightning safety. Where do you go to stay protected? Like, is it safe to be in a car driving down the road and have it be struck by one of these lightning bolts? You might be surprised the answer. That has happened before, and we will show pictures and we'll talk about that and lightning safety on tomorrow's weather school lesson right here at 2 o'clock on the Facebook page. So until then, we'll see you then. Oh, and of course, all the latest updates of the day's happenings on the TV side, the 411 at 4 o'clock and at 5, 6, and 10. We'll see you then for our next live news and weather update.